Dear viewers of my YouTube channel, I am extremely happy to meet you in yet another module, that is Success to Gate Control Systems Module 26. In the last module, that is Module 25, we have covered the questions covering controllability, observability and transfer function. So for which we have taken some gate questions pertaining to the disciplines electrical engineering, electronics and communication engineering, instrumentation engineering and chemical engineering. In this module, we will solve the questions pertaining to solution of state equations. And in the next module, we will cover the remaining questions in the state space analysis. Let me move to the presentation straight away. So the first question has appeared in GATE 2018 Instrumentation Engineering, question number 37. So consider the linear system x dot equal to, so matrix is given into x with the initial condition x of 0, 1, 1. The solution x of t for t. So they have given four options. Now, just by seeing these particular questions, what should come before our mind is we should get the expression for x of t. See, we already know that x dot equal to ax plus b. Of course, here b is not given, only x dot equal to ax is given. Therefore, if you take the Laplace transformation on both sides of this, s into x of s minus x of 0 equal to ax of s. Therefore, if you simplify this, this is si minus a into x of s, si minus a into x of s equal to x of 0. So now what is asked is x of t. So pre-multiplying the entire expression with si minus a inverse, si minus a inverse into si minus a is identity matrix, multiplied by x of s is x of s. Therefore right hand side also we have to multiply. Therefore it is si minus a inverse into x of 0. So that is what I am trying to mention here is si minus a into x of s is x of 0. I want x of t finally. Therefore, pre-multiply this by si minus a inverse. In that case, it is identity matrix multiplied by x of s is x of s. Therefore, right hand side also I have to pre-multiply with si minus a inverse. Therefore, si minus a inverse into x of 0. Now, I need x of t. So, how to find out x of t? So, we have to take the inverse Laplace transformation. So x of t is L inverse of si minus a inverse into x of 0. Therefore, what we should find out is from A, that is this is your matrix A. So from matrix A, you can find out si minus a and x of 0 is known. So use these two matrices and substitute here to get x of t. Let us see how to do it. First, we will find out si minus a. So, what is si minus a? So, si minus a is equal to s plus 1, 0, 0, s plus 2. So, this is your si minus a. Now, we need si minus a inverse. Therefore, we have to find out determinant of si minus a. What is determinant of si minus a? So multiply the diagonal elements. So s plus 1 into s plus 2 minus 0. Therefore it is s plus 1 into s plus 2. Now I need inverse. So what is si minus a inverse? 1 divided by si minus a. So 1 by s plus 1 into s plus 2. Right? So 1 by s plus 1 into s plus 2 into adjoint of si minus a. How to find out adjoint of si minus a? Interchange the diagonal elements, change the signs of diagonal elements. So that is what I have done here. So this is your adjoint. So this is your adjoint matrix, adjoint of si minus a, and this is your determinant. So this is your determinant si minus a, right? Therefore, Si minus A inverse is finally, so if you simplify, it is S plus 1, 0, 0, S plus 2. Right. Now what we need is X of t. So how to find out X of t? So X of t is L inverse of Si minus A inverse, that is S plus 1, 0, 0, S plus 2 into X of 0. So what is your X of 0? 1 and 1. So if you find out the L inverse of Si minus A inverse, so we will get e power minus t, 0, 0, e power minus 2t. See, actually, yeah, L inverse of, I think we have made a mistake. Yeah, here it should be 1 by S plus 1. This is 1 by S plus 2, right? That is 1 by S plus 1 here. Here again 1 by S plus 2. So 1 by S plus 1, 1 by S plus 2. I think now it is correct. So when we have divided S plus 2 by, S plus 2 by S plus 1 into S plus 2, S plus 2, S plus 1 cancel each other. So 1 by S plus 1, 0 by this is 0, again 0 by this is 0. S plus 1 by S plus 1 into S plus 2 is 1 by S plus 2. I think instead of writing 1 by, I have simply written S plus 2. Please change it. Therefore, 1 by S plus 1 inverse Laplace transformation is e power minus t. 0, 0. For 0 again 0. 1 by S plus 2 e power minus 2t. So, I think now we can close it. So if we are closing it, that means multiplied by that 1 and 1. So that means this matrix will come here straight away. So multiplied by this, right? So therefore e power minus t 0, e power minus t 0, e power minus t 0, 0 e power minus 2t into 1 is which option? So it falls into option D. So since it is option D, I am writing here for the space constraint, I am writing here. So option D is correct. So option D, that is this I am writing here, option D. I hope you have understood. Let us move on to the next question. So next question again, solution of state equations. So it is asked in GATE 2017 electrical engineering question paper. So in GATE 2017 electrical engineering question paper, set 2, question number 46 has appeared. So consider the system described by the following state space representation. x1 dot x2 dot equal to 0, 1, 0, minus 2 x1 of t, x2 of t plus 0, 1 u of t, and output equation is y of t is equal to 1, 0, x1 of t, x2 of t, and if u of t is unit step input and x1 of 0 equal to x1 of 0, x2 of 0 is 1, 0, the value of y of t at t equal to 1 second is dash. That means they have given the state equations and output equation, initial condition. Output is asked. In the previous question, what we have found out is x of t. Now we want y of t. What is y of t? Y is equal to cx. That's all, because y is equal to cx. Therefore, I need this x1 of t, x2 of t. That means this is again solution of state equation problem. Let us see how to do it. Here matrix B is also there. So matrix B is also there. So we will work out the solution. So let us see the solution. So this is your matrix A and this is matrix B and this is matrix C. Now we need Y, so Y is equal to Cx, that's all. Therefore we have to solve for X, that means we need X of t, right? So we need X of t. What is X of t expression? We already know L inverse into Si minus A inverse into X of 0 if input is not there. Previous question. Now input is also there. Therefore, we get this expression L inverse into Si minus A inverse into B U of S. Right? So that is if you take the Laplace transformation, that is x dot of t equal to ax plus b, you take the Laplace transformation, then rearrange the terms, write x of s expression, then take inverse Laplace transformation, then you will get the expression that I have written just now. Therefore, what I need is Si minus A inverse as usual. I also need Si minus A inverse into B into U of S. First, let us find out Si minus A inverse. So for that I need Si minus A. So what is Si minus A? So S plus 2 minus 1 0. So this is your Si minus A. S plus 2 minus 1 0. Now I want Si minus A inverse. So how to find out Si minus A inverse? So 1 divided by determinant value. What is the determinant value of this? S square plus 2s plus 1 or s into s plus, sorry, s square plus 2s. That is s into s plus 2. Into adjoint. What is adjoint? Interchange the diagonal elements. Change the signs of off diagonal elements. That's all. Interchange the diagonal elements. So I have interchanged the diagonal elements. S plus 2 I have interchanged positions. Then signs of off diagonal elements, minus 1 I have made plus 1 0 0. Now if you simplify this, so Si minus A inverse will be, so s plus 2 by s into s plus 2 is 1 by s, then 1 by s into s plus 2, 1 by s into s plus 2, then I think here it is yes, I'm sorry, this is yes, right? This is yes. Therefore, yeah, 1 by s into s plus 2. So this is okay. This is yes. Instead of 0, I have to take. Anyway, I will highlight it properly. So this is here yes. This yes has to come here. Therefore, here you will get 0. Here s by s into s plus 2 means 1 by s plus 2. So it is 1 by s plus 2. Anyway, I will write it neatly in the next slide. That is Si minus A inverse is equal to, what is Si minus A inverse is equal to 1 by S, 1 by S into S plus 2, 0, 1 by S plus 2. That is what I have written in the previous slide. Right. Now Si minus A inverse is known to us. Now we have to find out L inverse into Si minus A inverse into X of 0. That is one thing. Okay, so let us straight away substitute. So x of t is equal to L inverse. So L inverse of Si minus A inverse into x of 0. So 1 by s, if you take L inverse, it is 1. 1 by s into s plus 2, 1 by s into s plus 2. If you take partial fraction, this would be 0.5 by s, then minus 0.5 by s plus 2. 0.5 by s, that is on partial fraction you will get this. Therefore, if you take inverse Laplace transformation, what do you get is 0.5 minus 0.5 into e power minus 2t. 0.5, 0 minus 0.5 e power minus 2t. So for this 0 only. 1 by s plus 2, we know it is e power minus 2t. So this multiplied by, so L inverse of Si minus A inverse we have done. X of 0. What is x of 0? 1, 0. Plus L inverse of Si minus A inverse. L inverse of Si minus A inverse. That means I should write 1 by S, 1 by S into S plus 2, 0, 1 by S plus 2, 0. That is L inverse of Si minus A inverse into B into U of S. What is U of S? First step input it is 1 by S. So this on simplification, what do you get is, so this 1 into 1 is 1 plus 0, 1. So here it is 0. That is when I multiply the first two matrices plus. So I have to multiply the other two matrices, that is 1 by S into S plus 2, 1 by S plus 2 into 1 by S, correct? So L inverse of 1 by S into S plus 2, the first element. Second element is 1 by S plus 2. That is when the L inverse of the 2 by 2 matrix is multiplied with the matrix B. Right. Now this again we have to do the partial fraction. So if you do the partial fraction and take inverse Laplace transformation, so if you do the partial fraction and take the inverse Laplace transformation, so you get 1, 0. Anyway, here 1 by S square into S plus 2. So therefore A by S square plus B by S plus C by S plus 2. The second one is 1 by S into S plus 2. Some A by S plus B by S plus 2. That you have to take inverse Laplace transformation. After taking that inverse Laplace transformation, what you get is 0.5t minus 0.25 minus 0.25 plus 0.25 into e to the power minus 2t. And here 1 by S into S plus 2 on inverse Laplace transformation after doing partial fraction, 0.5 minus 0.5 into e to the power minus 2t. So if you add this, what you get is 1 minus 0.5 is 0.75 plus 0.5t plus 0.5t plus 0.25 into e to the power minus 2t. So that is the first element. Second element in that vector is 0.5, because 0 plus 0.5 minus 0.5 e power minus 2t is this. So now we got x of t. So what we have to do is y. Y is only asked. 1 into 0 into x of t. Therefore, this entire thing has to come here. And here you will have two elements, right? So these two elements, right? So these two will come here. So if you simplify, you will get 0.75. That is only the first element will come on multiplication with 1 plus 0.5t plus 0.25 e to the power minus 2t. Now the question is, what is y of t at t equal to 1? So substitute t is equal to 1. So if you substitute t is equal to 1, it is 0.75 plus 0.5 plus 0.25 into e to the power minus 2. And if you simplify this, you get the answer as 1.2838. So 1.2838. Anyway, I'll write here also this 1.2838. Let me write here for clarity. So So 1.2838. Is it right? So that is the answer that you get. So let us move on to the next example. Now, almost a similar question. It has appeared in GATE 2016 Electrical Engineering Set 1 question paper. So what is asked is y of t at t equal to logarithm 2 base e, that is natural logarithm of 2. So how we have to do? Same method. So first we know the matrix A. This matrix C is known. X of 0 is known. Now, how to find out Si minus A inverse? So for that, first you have to do Si minus A, S minus 1, S minus 2, 0, 0. Therefore, next step is Si minus A inverse. Therefore, 1 divided by determinant of S minus A, that is 1 by S minus 1 into S minus 2, 1 by S minus 1 into S minus 2 into, so for finding adjoint, interchange the diagonal elements, change the signs of diagonal elements. Therefore, Si minus A inverse will be 1 by S minus 2, 0, 0. So this is actually 1 by S minus 1, I'm sorry. So this is 1 by S minus 1 and this is 1 by S minus 2. So now we know Si minus A inverse. Now what is required is, anyway matrix B they have not given. Therefore our job is very easy. So first we have to find out L inverse of, that is we have to find out X of t. What is X of t? L inverse of Si minus A inverse into X of 0, right? So what is X of 0? 1, 1. So L inverse of Si minus A inverse. So 1 by S minus 1 inverse Laplace transformation e power t, 0, 0, e power 2t, 1, 1. Therefore, this would be, that is, this is X of t. Now, in the next slide, we will see Y of t. What is Y of t? So, X of t is this. So, e power t is 0, yeah. So, this is e power t, e power 2t on simplification, right? E power t into 1 plus 0, 0 plus e power 2t. Now, we need y. What is y? Y is Cx. C is 1, 1. Actually, C that they have given in column matrix form. Well, now we have to write in the row vector form. Therefore, maybe we can write it as Ctx. So Ct into x. Just now we have found out e power t, e power 2t. So if you multiply this, e power t plus e power 2t. Now we are asked at t is equal to log a base 2. Therefore, we should substitute t as logarithm base 2, that is natural logarithm of 2 plus e to the power of logarithm, that is e. So 2 into, that is 2 times t, right? So 2 into natural logarithm of 2. Of course, that 2, if it is brought to this side, it is e logarithm. So in the next step, even we can write log 2e plus e to the power log e to the power 4. This 2 will come here, 2 square, right? So if you use your calculator, you will get 6. So 6 is the answer. That's all. So let us move to the next question. So here, almost a similar question, but they are not asking what is x1 of t, x2 of t. They are asking what is steady state value of x1 of t, x2 of t. That means we have to find out what is limit t tends to infinity x1 of t, then what is limit t tends to infinity x2 of t. See, we can do this in this way. We know by final value theorem, limit t tends to infinity x of t is equal to limit s tending to 0 s times x of s. Limit t tends to infinity x of t is limit s tending to 0 x of, because steady state value means we want this only, right? Therefore we have to write the expression for x of s, from which we have to take s into x of s, then as s tends to 0 what is that value we have to do. That's all. And we know the expression for a. Anyway, this is your b. U they have not given, that means it is unit step. It is unit step because unit step means it is 1, no? That is why they have not explicitly given. And this is your initial state, that is x of 0. Now we have to write the expression for x of s. So what is x of s? We know. So limit s into 0. X of t means L inverse of all that we do, no? So now what we need is s into x of s. That means si minus a inverse x of 0 plus c into, right? So si minus a inverse into x of 0 plus c into si minus a inverse into b u of s, right? So this term is due to initial condition and this term is due to input, right? So there are two terms, right? So anyway we need si minus a inverse, then c into si minus a inverse into b. That's all. Then you have to multiply with s. So we can find out si minus a first. What is si minus a? S minus 1, s plus 4, 2, 3, right? So s minus 1, s plus 4, then minus 2, 3. So this is going to be your si minus a. Now we will see how to find out si minus a inverse. So si minus a inverse is needed. So si minus a inverse means 1 by more determinant of si minus a, that is s minus 1 into s plus 4 plus 6. So if you do that, it is 1 by s square plus 3s plus 2 whole thing multiplied by s plus 4 2 minus 3 si minus 1, right? So this is your this minus 3, I'm sorry, this is minus 3, right? Because we have to change the diagonal elements position, interchange, then change the signs of the off diagonal elements, right? Now we will go for computing the two terms, right? So we will go for computing those two terms. What are those two terms? That is so we have to find out si minus s into si minus a inverse into x of 0, right? S into si minus a inverse into x of 0. Anyway, x of 0 is 0. If you see, x of 0 is 0. In the previous slide, x of 0 is 0. Therefore, L inverse of si minus a inverse x of 0, because this multiplied by 0 0 is, anyway it is, what is that, 0 only. So it's a null matrix, right? Now anyway, this L inverse is not required. Anyway, we don't want the time domain expression. This is not required. So S into Si minus A inverse into X of 0 is 0. The next thing is S into Si minus A inverse into B into U of S. S into Si minus A inverse into B into U of S. That only we need. Yes. What is Si minus A inverse? 1 by S square plus 3S plus 2 into S plus 4 minus 2, plus 2 minus 3 S minus 1. What is U of S? Next multiplied by B. So we know what is B. 20, 10. U of S is 1 by S. That S will cancel with this S. Therefore, this is S plus 4 into 20. So 20S plus 80 plus 20, that is 20S plus 100. Then here 10S minus 60 minus 10. So 10S minus 70. Therefore, this they are multiplied by 1 by S square plus 3S plus 2. Therefore, what is x1 of s? So, x1 of s is 20s plus, that is s into x1 of s, because we are multiplying with the s. So, s into x1 of s is 20s plus 100 by s square plus 3s plus 2. Therefore, limit t tends to infinity, x1 of t is, so we have to substitute as s tends to 0, what happens to this sx1 of s. Therefore, 0 plus 100 by 0 plus 0 plus, so 100 by 2, 100 by 2, it is 50. Similarly, s x2 of s is 10s minus 70 by 10s minus 70 divided by s square plus 3s plus 2. Therefore, we need a limit t tends to infinity x2 of t. S x2 of us we know. Substitute s as 0. So, minus 70 by 2, minus 70 by 2. That means minus 35. Therefore, we have to see 50 minus 35 which option. So, 50 minus 35 which option if you see, right, it is option D. So, option D is correct. So, let us move to the last question. So, this is again a question from solution of state equations. A slightly different one. They are asking us to find out what is limit t tends to infinity of square root of x1 of square plus x2 of square. So, they need square root of x1 of square plus x2 of square. That means again we need x1, x2 only. Here we cannot use final value theorem because it is coming inside the square root. So, as usual, we know this is matrix A, this is matrix B, and this is x of 0. So, we need to find out x of t. So, for finding x of t, what is required? So, what is required for x of t is si minus a. So, first we will write si minus a. So, si minus a is s plus 9, 0, 0. So, the next step is to find out si minus a inverse. So, we need si minus a inverse. What is si minus a inverse? 1 divided by determinant value of si minus a. That means 1 by s into s plus 9 into adjoint of s minus a. That means interchange the diagonal elements, change the signs of off diagonal elements. That means this is 1 by s, 0, 0, 1 by s plus 9. So, this is your si minus a inverse. Now, we need L inverse of si minus a inverse first of all into x of 0. then L inverse of Si minus A inverse into B into U of S. So let us do it in the next slide, right? So let us do it in the next slide. That means we need x of t. What is x of t? L inverse into Si minus A inverse into x of 0 plus same expression I am writing, that's all. L inverse into Si minus A inverse into B into U of S, right? So L inverse of Si minus A inverse. Si minus A inverse we have already written in the last slide. So if we take the first element of for Si minus A inverse, L inverse, if you do 1 by S 1, for 0 0 0 0, 1 by S plus 9, it is e power minus 90 into x of 0. So the x of 0 is 0 0 as per the specifications given. Then L inverse of, so Si minus A inverse 1 by S 0 0 1 by S plus 9 into B. What is B? 0 45 into U of S, unit step 1 by S, right? So if you multiply the first two matrices 0 0 plus L inverse of, so if we do that 1 by S into 0, so that is 0 0, here 45 by S plus 45 by S plus 9 into 1 by S, that is, what do you get is 0 0 plus L inverse of 0 45 by S into S plus 9, and this 45 by S into S plus 9, this 45 by S, therefore this is 0, therefore we have to find out only this. Let us do in the next slide. So 45 by S into S plus 9, if you take partial fraction and then simplify, we will get 5 by S, then minus 5 by S minus 5 by S plus 9. Therefore, your x of t is L inverse of 0 divided by, for this we have to find out L inverse. That means 5 by S minus 5 by S plus 9, which is equal to L inverse, if you do 0, 5 by S it is 5, 5 by S plus 9 it is minus 5 into e to the power minus 90. Now if you see here, x1 of t has come, this is your x1, this is your x2. So what is asked? Limit t tends to infinity square root of x1 square plus x2 square. So x1 square is 0. So square root of x2 square, that is 5 minus 5 into e to the power minus 90 square. Right. As time tends to infinity, what happens is this term will shrink to 0. E power minus 90 will be 0. Therefore, this is simply limit t tends to infinity square root of 5 square minus 0, which is equal to 5. So 5 is the answer. See how easily we were able to solve all the questions in GATE pertaining to solution of state equations without any difficulty, just by substituting Si minus A inverse, then finding L inverse of Si minus A inverse into x of 0 plus L inverse into Si, C into Si minus A inverse into B into U of S for x of t. From that y is equal to Cx. So only two expressions. So one is find L inverse of Si minus A inverse. From that find out x of t equal to L inverse into Si minus A inverse into x of 0 plus L inverse of C Si minus A inverse B U of S. Second, y is equal to Cx. That is Cx means if you have two elements, the each element you have to one element you have to multiply by x1 of t, then second element in C matrix you have to multiply x2 of t. Then depending upon the question asked, you have to answer. I hope I have made justice of solving all the questions. So I hope you have understood. So if you have any doubt, you can refer this video. This video I have already uploaded in my control systems lecture series, lecture 31, solution of static equations. The URL of the same is given here. Still, if you have any comments or queries or feedback, you can post it to this mail ID or even you can WhatsApp to this number. So you can share my videos and subscribe my channel to reach the huge section of learning community. Till I meet you in the next module. Thank you and goodbye.